So we previously discussed the idea of how companies should focus on innovation that could benefit our society, economy, and the future generations. But we also want to hear the experiences from those who are already building solutions at the forefront of sustainability and building solutions that already aim to reduce the carbon footprint. So I'm welcoming to this virtual stage Guillaume Pic-Rivière with his keynote on low-tech ocean plastic recycling and potential applications to boat building.
Yeah, hi. So to follow on what you just said, I can just present myself. So I'm currently working for a startup company in Northwest Scotland that is trying to set up low-tech solutions to recycle plastic from the ocean, plastic pollution that comes to the shore from the ocean. And I try to go one step further by developing what I call the clean skiff process, which is a process to apply those low-tech technologies to boat building. So yeah, let's focus first on how this on the sector. Yeah, sorry. So let's focus on the economy of leisure and work boats, small work boats, up to, let's say, 12 meters. Well, this sector is worth quite a lot of money, actually. You might seem it's trivial, but it's not. Like those figures here are just for Europe and for the leisure boat industry, and you can see it's already employing like 3.5 million people throughout Europe. And let's say that also it's one of the sectors where Europe exports way more than it imports. Europe is actually exporting a lot of leisure boats to the whole world, to Asia, to the United States, and well, there's a lot of countries involved. France is historically quite big in the sector, but also Poland, also the Netherlands. And so, yeah, it's really important in Europe. It's quite a big sector. So, yeah, let's move on to what is worrying in 2021, which is in this sector, the ecological concerns. Indeed, this sector uses non-recyclable and non-biodegradable technologies such as glass-reinforced polyester, steel, aluminum, and to get ideas fixed. You can tell yourself that with the amount of glass-reinforced polyester that is produced per year, just to build leisure boats throughout in the whole world, you could cover the area of Riga more than 100 times each year. So it's like 45 times the area of New York as well, and each year. So it's quite a lot of material produced. It's 1 million ton per year. The result of that is that in a few years, we might be confronted to a lot of those boats ending up as wrecks in rivers, in shores, on shores, and throughout Europe. Like in France, it has already begun because the industry is quite old, and you have a bit less than 10,000 old wrecked boats that end up on the shores by year, and it ends up in microplastics, visual pollutions, chemical pollutions with anti-fouling paints, all sorts of pollutions, like fluid pollution with the oils, the engine oils and all. And so it needs to be taken care of. So as I said previously, the problem with glass reinforced polyester, which is the main material we build those boats currently, is that it's not recyclable, it's not biodegradable, it's completely sourced from petroleum, from oil, which is quite problematic now, because imagine you end up with like no oil at all, which is not coming in short future. But anyway, imagine you don't have any more oil, you can't build boats, you can't build anything in plastic actually. So yeah, speaking about carbon footprint, it's 10 to 20 tons for an average size boat of 9 meters, 4 tons. And for maybe you know about offshore racing, sailboats that go around the world, like the Vendée Globe or something. Those races use boats that need 200 tons of carbon footprint per boat. So you might assume that sailing is clean because it uses a sail and the energy of the wind, but actually now there's a big paradox between this idea and the reality of the industry that pollutes quite a lot. Like you can tell yourself that it's more than 50% the carbon footprint of all the population of Latvia's, only for these industries. This industry. So yeah, it really needs to be taken care of. There's a few current solutions that are mainly using natural fibers and resin in composite materials. Well, you can use flax and bamboo fibers and biosourced resin. So I don't know if you know that, but like a composite material is made of a fiber and a resin. Like you can, the more frequent one on land is, for example, reinforced concrete. Concrete, you have concrete, and inside you have steel that basically you have steel fibers in that steel rods, and so the steel is the fiber, and the resin is sort of the concrete. So in boat building, we use composite materials a lot because it's light, it's efficient, and we're thinking of using natural fibers. But there's a bit of a problem because there's still no real recyclability, because to recycle a material, a composite material, we need to get the fiber of the resin, which is quite complicated to do. And we don't know how to do that in an energy efficient way, actually. And also it needs space, because when you have natural fibers like flax, for example, you need space. You need agricultural space, a lot of it. Like you might use several thousand square meters of cultures just to make like one boat, and you could have used all those cultures to make food for people. And we know that feeding people is going to be one of the big problematics of the 21st century with a growing population. So we can think of other solutions. And actually, getting plastic out of the ocean and recycle it is quite relevant in that situation. We draw inspiration from two main projects that are on the left. You can see here. or to say innovation that makes kayaks out of recycled plastic that comes from the ocean. And on the right, you've got actually the biggest current boat made in ocean plastic. Now, it was made in Africa by traditional carpenters that used plastic instead of wood. Then they made molds of the wooden pieces and assembled a big, like 7-ton boat out of the plastic they found on the beaches. And this boat is actually sailing, and there they plan to make a bigger one. So actually making boats out of recycled thermoplastic that comes out of ocean pollution is quite relevant and possible. And the big advantage from the environment point of view is that when you build a 1-ton boat, you get 1 ton of plastic out of the ocean, which is really interesting. Like, you're not minimizing your impact, you're actually making things better, which is one step ahead in ecology. So the process, what we plan to do is make beams out of shredded old fishing nets and ropes using shredder and extruder, and actually strip plank a boat as it's done in wooden boat construction. As you can see here, very thin beams are glued together and assembled over a frame, a skeleton, to make a boat. And so we might be able to do that out of all fishing nets and ropes, and like weld all that using heat guns and welders. And this we can like this process has a lot of advantages actually. Like, you can make quite quality boats. They're weather and wear resistant because the plastic we will use, fishing nets and ropes, are already good quality plastics that are made for hostile environments. Also, this process uses an external structure that is not present in other kinds of thermoplastic boat building, as rotomolded boat building, where you don't have an internal structure, so the boat will be lighter. And also, you could see on the previous picture that there is no need for molds. Usually when you use plastic, like thermoplastics, you need molds. And with this process, you don't need that. So you can make small series and custom design, and you have low machine investment, which is quite interesting. So yeah, the work. We plan to develop low-tech efficient machines to get to go from the ropes to a plastic melt, and then make beams out of it, then prototype it. Of course, we need to prototype the machines and make a prototype boat. This is what we plan to do in the future. For that, we're working with Plastic at Bay, which is a startup company in Northwest Scotland that do a really nice work on low-tech machines, low-tech ocean plastic recycling machines. A lot of the work they do is completely open source. So you can just go check on their website what they do. It's really interesting. They do a really lot of work. And so we share the whole development of machines, and especially like the dies, which is the piece that go at the very end of the extruder to make the beams. And also, we got help from the business incubator at the INSA Rennes in France. It's a business incubator in an engineering school that is helping us with prototyping, because they got machines to do prototypes. So yeah, we have those two partnerships. And so here you can see an extruder from Plastic at Bay. So it's this kind of machine that would that will allow for rope from making beams out of ropes. So first you need to, for the purpose, manual cut the ropes, which is quite a problem. In the future, we'll need to have an automated way of doing that. But for now, for research and development purposes, it's just manual cutting of the ropes. And then shred them, and then use a custom extruder to get the melt, the melted plastic. And then from the melt, you need to do beams. And how to make beams? Well, without a mold, you need an extrusion die. What's difficult with that is you need to have an even cooling, because the cooling is dynamic as opposed to in a mold. And so it needs complex and expensive simulation tools. And for that purpose, we developed our own open source simulation tool that allows for the computing the fluid dynamics and the thermics in the dies, extrusion die, and potentially the whole machinery. So this will be completely open source and released by January. So you will have access to it if you want. We'll discuss that later. So yeah, the work to be done in the future is prototyping a die adapted to boat building, because the one we did now are actually dies that are used for other purposes, fence post and eventually pellets and all, and other kinds of industrial and agricultural purposes. And so we need to do some adapted to boat building. And also we need to carry out extrusion tests that are carried out by Plastic at Base at the moment. They just begun, and it's really encouraging. Like this is looking quite good. The extruder prototypes are working quite well, thanks to all the Plastic at Base work. And then we'll need to make a prototype boat, which is a big step. The big step to show that the process is really worth it and really efficient. So yeah, as I said before, the open source simulation tool will be released on GitHub by January. So please just write your email in the chat if you're interested, and I'll send the link when it's done. And yeah, we need everyone's help to improve the simulation. That's the very principle of open source. The simulation we made is free compared to other ones made by, for example, Dassault system with Abacus. This is really an efficient software, but it's really it's like 30,000 euros a year, the license, and you need to buy it everywhere, so it's not possible for small companies. So we're releasing an open source tool in Python, but we need some help to get it to do it like a realistic way. It's done, it works, but it needs a bit more of improvement to be really efficient and to work as it's supposed to. So yeah, as in every open source work, every help is welcome. So if you're interested in Plastic at Base work on ocean plastic recycling, or in the clean skiff process that we are developing that adapts it to boat building, just send me an email if you want, and we can I can explain things. I can give access when it will be done to the GitHub simulation and all the open source work we are carrying on. Sorry. Yeah, I hope all this was understandable and that it was interesting and that it gives a bit more hope for the future of all kinds of industries, and that hopes to be able to make things while making our environment better and not worse, which is a very principle of what we're doing. We're trying to make the industry cleaning the ocean, which is quite a challenge. But yeah, I hope it gave you some hope. Thanks.